Hey, welcome back. Suppose we have an object that we want to extract some of its properties values into separate variables. In order to do that, we need to declare a variable for each one of the properties, then use the dot or the bracket notation to get the values from the object. In this case, this method works fine, but imagine if we had 20 or 30 properties to extract, with some of them being nested in objects and arrays, which happens often since the rise of popularity of the JSON format to store data. I'm pretty sure you agree that it would be one of the most boring and repetitive tasks to do as a developer. Well, thankfully ES6 introduced Destructuring to reduce the work needed to achieve that, and with that I mean extracting specific information from objects and arrays as well. So let's get started with array destructuring. Say we have an array with 3 elements that we want to store each in a separate variable. To do that, we need to use the keyword var, let or const to define the type of the variables. Then we need to set their names within a pair of brackets, followed by the equal symbol in the array containing the values. That done, now we have 3 constants, C1, C2, and C3, each holding a value from the colors array. That said, we can fill existing variables with the values, so here we have these variables initialized, then they get reassigned with the values from the array. We have also the ability to skip values, so say we want to create variables for the first and third elements only. To do that, we just simply need to remove the identifier of the second variable, but keep the commas before and after it. As you see, we get an error message because obviously we are trying to access a variable that doesn't exist, which is C2. In case we add a fourth variable to the destructuring statement, if there is no fourth element in the array, that fourth variable will be set to undefined. Furthermore, we can set a default value for C4, so if there would be a fourth element in the array, it will be assigned to it. If not, C4 will keep that initial value. We have also the ability to extract certain elements into discrete variables while assigning the rest of them to a single variable as an array. So in this case, C1 contains the first element of the array while the rest is assigned to C2. As you know, we can have nested arrays within an array, but them being nested doesn't change that they follow the same rules when it comes to destructuring. So for example, say we want to create 3 variables that hold the first element of the colors array and both elements of the nested one. To do that, we need to set the first variable, then type a couple of commas to skip the second element and another one to skip the third, then set the 2 variables which will be filled with the nested array elements, wrap it in a pair of brackets. Again, nested arrays follow the same rules, thus we can skip the first element if we want to. Array destructuring is also very useful when it comes to swapping values between variables. Here is an example. Suppose we have a couple of variables a and b that we want to swap the values they contain. The typical way of doing that is by creating a third variable that holds the value of a before it gets replaced with the value of b. Then b gets reassigned with the value of c. Now with destructuring we can do that in a single line. All we need to do is to set a and b between a couple of brackets like we do in a usual destructuring statement, then do the same at the right part of the equal symbol but in a reversed order. So here we are basically reassigning the variables a and b with values from an array created from b and a. The last thing to mention when it comes to array destructuring is that we can use it to define functions parameters. This method of declaring an array as a parameter adds clarity to the function's definition because we are given more information about the parameter. So here we are telling the user of this function that it does not only accept an argument, but we are literally telling them that this function accepts an array and that it should have exactly 2 elements. Enough with arrays. Now, to extract values from objects, we need to type the keys of the properties followed by a colon, then the names we want for the variables. All of that wrap it in a couple of curly braces. Then, like we did with arrays, we need to type the equal symbol followed by the object we want to get the values from. So now we have the value of the fName property stored in a constant named first name, and the value of the lName property stored in a constant under the name of last name. We can set the same identifiers used as keys as names for the newly created constants. Actually, that helps to create more concise code, because in the case where we have the same names of variables set as keys, we can get rid of the colons in the variables' names. Again, we can assign the values to variables that already exist. However, this might be a source of problem as shown, because the engine in this case interprets the left side of the assignment as a block of code instead of a destructuring assignment. To fix that, we just simply need to set all that line of code within a couple of parentheses. As you know, we can use the brackets notation to set keys for computed properties, so to extract the values from such properties, we need to use the same notation as we did earlier, except that here the name of the property is typed the same way as it is in the definition of the object. Thus, we need to type the name of the variable holding the key of the property between a couple of brackets, then a colon followed by the name of the variable we want to create. Same as arrays, objects can have nested elements. Therefore, to get the value of a certain property situated in a nested object, we need to set the key of the property that holds the nested object, a colon, then an opening and a closing curly brace, and in between them the key of the property that we want to extract, followed by a colon and the name of the variable, or again we can skip the name of the variable if we want to use the same name as the key of that property. You have to pay attention to the names of the variables though, because you might stumble upon cases where you use the same variable name for more than a single property. Here is an example. Say we have another color property in this object. Now, to extract its value, we would choose color as the name of the variable, but here an error message shows up even if the syntax is correct. Well, that's because we used the same constant name for the eColor in the variable created to contain the value of the color property in the nested object. That said, we need to change the name of one of the two constants. Now, one of the best practices when it comes to functions is to set the required parameters individually, then use an object as a last parameter containing all the optional parameters. And again, we can use Destructuring to give more information about the properties that the object passed as argument should contain. Although this is a good practice, it still has a weak point, because say we skip the optional parameter here, what do you think the result will be? As you can see, calling the function without a third argument, which is supposed to be optional, causes an error. When we use destructuring in a function's definition, we are basically doing the same thing as regular destructuring, except that we are postponing the right part of the assignment until the moment of the function's call. So with that in mind, in our example, at first when we called the function with the third argument, it worked. However, when we called it again but skipping the optional argument, we got an error because the destructuring assignment got undefined on its right side instead of an object, which is not allowed. So to fix that, we can set an empty object as a default parameter, which is again different than null or undefined, therefore it is allowed. We can enhance the workaround by setting default values to the arguments to avoid having them filled with undefined after an optionless function call. Finally, we can apply mixed destructuring to objects that have a mixture of nested objects and arrays. That being said, let's apply that as an exercise. So here, let's try to get the value of the property named first in a constant named first name, and the third element of the music array in a constant called favMusic. And there we go. So this is it for this part of the series. So make sure to subscribe and I will see you in the next one.